Hi there, this is Dr. Embody with Project 9. You'll be glad to hear that Project 9 is shorter than Project 8. A little bit of a relief after that last one. This time we're doing some cryptography. Happens to be my area of research, so it's kind of interesting to me. And what we're going to do is we're going to use two different methods to decrypt some files. So you're given something that's encrypted, and what does it decrypt to? These two are quite unrelated. There are some similarities, but you want to think of them as kind of two different things in terms of this project. In terms of how you're going to approach them and so on. On this particular video, I'm not going to write any code, and hopefully that will make sense as we go through this. So with that, let's take a look at the project. I'm going to scroll right down to the project description. We have the old we're going to open the file, and now we have two sort of supporting functions, and these two functions, this one and the next one, they're going to support just one of the two types of decryption that we're going to do. All right, so this is a log probability dictionary that we're building, so it's going to return a dictionary, and guess what? We give you the equation for that. I'm not going to say anything more about it because I believe at this point you can build that function just fine. All right, same with the next one, which is the fitness calculator. And for this one, you are going to do, you're going to take a potential plain text. So I'm going to give you, you're going to pass in this plain text and this dictionary that was created in the previous function. And what you're going to do is you're going to create a score for this particular plain text. So if I gave you hello as a plain text, then you would create some kind of a score XYZ here, and return that value. Again, using the quadrigram dictionary that was created in the previous function. So those stand alone. I think that you'll be able to do those without me saying any more about it. And this second function, which uses the first function, it is used to support the second one of these decryption tools that I'm going to talk about. So build those, get those tested, and then you can go work on the other functions. And the first one I'm going to talk about is this one that is called the chosen plain text attack. So we do have so we're gonna take a look at this guy here, and the chosen plain text, what it does is you have three inputs. You have a plain text and the corresponding ciphertext, that is the encrypted version. And from this you're going to build a dictionary using this int, and I'll talk about that more in a moment. And from this information you build the dictionary. Then you use this dictionary that you created to decrypt the text. That's the third, that's the fourth argument to my function. Right? So we take the first three pieces of information, build a dictionary. Then we use that dictionary to decrypt the text that's given us. Let's take a little closer look at this. And the part I want to focus on is down, is what actually starts down here. So suppose ABC is the plain text. That's that. And suppose this weird collection of characters is the ciphertext. That's that. And suppose the bifurcation size is 2. That would be that. Okay. And what you do, what that means is we're going to take this, that is the string with the O, the C, an O, a D, an O, and an E, and we're going to build a dictionary. And the dictionary is going to have pairs of out of the ciphertext mapped into individuals out of the plain text. So, for example, we will what we will do is do something like, oops, bad color choice there. Here we go. Is because my bifurcation is 2, right? So let me clarify this. So I've got, I'm assuming my ciphertext is this OCODOE. I'm assuming my plain text is ABC. And my bifurcation is 2, so that's a 2 for that value. So that means I take my ciphertext and I take the first 2 characters, and that now becomes a dictionary entry. OC maps to, so the first pair out of here, it's a pair because that's 2. If that was 4, I'd be looking at 4 of these, goes to the first one here, which is an A. Then I look at the next 2, and again it's 2 because my bifurcation side is 2, and I see that OD maps to A. So OD maps to A. I'm sorry, let's try that again. OD maps to this, this being the second pair, maps to the second character in there. That's the character B. And then finally, the next pair maps to the next character, which is C. So OE now maps to C, and I've reached the end of my ciphertext, so there's my dictionary. So I build this dictionary. Now that I have the dictionary, what do? Well, I'm given some kind of text to decrypt, and now I'm going to go through that text, grab 2 characters at a time because of this 2. I take those 2 characters, I look it up in my dictionary, and I create a new plain text. Okay. And that's all there is to it. So again, I start with these 3 items, the plain text, the ciphertext, and the bifurcation, such as ABC as a plain text, OCODE as a ciphertext. I walk through the ciphertext using the bifurcation, in this case 2 characters, maps to that, the first 2 characters here maps to that character, that gives me the first entry, and so on. So for example, suppose my text to decrypt was ODOC. Okay. How in fact would I do that? Then what I would do is I would grab the first 2 characters. And how do I know it's the first 2 characters? Because the bifurcation is 2. OD, maps to B, so the first character of my plain text is B. Then I go back and I grab the next two characters, Y2, because that's my bifurcation. I look up OC in my dictionary. I see OC maps to A. I'm now at the end, and I see that my plain text is Ba. So, basically 2 steps. Step 1, build a dictionary. Step 2, use that dictionary to decrypt our text to decrypt. Right? So that's 2 steps, build a dictionary out of the first 3 items, and then use the text to decrypt and actually decrypt it. Right? That's one of our functions. It need not be a long function. I think mine was like 20 lines of code. Much less than what we were doing with last time. All right, with that in hand, let's take a look at the other one. Okay. And in this case, I have a ciphertext and I have a quadgram dictionary. Where did that second one come from? Well, let's go take a look. Back up here, I built a dictionary. That dictionary. That's my quadgram dictionary. Okay. And so I use that to do my decryption. So we'll go back down here again. And what we're, so that's the input. What's the ciphertext that I need to decrypt, and then this quadgram dictionary. Now, unlike our previous one, the quadgram dictionary helps me score my attempts. And we call this brute force because I'm going to try every possibility and give it a score. The one with the highest score will hopefully be the best decryption. And what this is what's known as a Caesar cipher, named after Julius Caesar. And the way it works is that you map with what's sometimes referred to as a shift. What do I mean by that? Well, let's suppose that I have this shift of 1. That means that A maps into a B, and B maps into a C. What's next? Oh, C maps into a D, and so on. And what I would do is with key 1 is I'd build this entire dictionary of this mapping. And then I use that dictionary to try to decrypt my ciphertext. So I just go through, use this dictionary, and say, all right, let's assume this is the right mapping, and I'll go and decrypt it. Is it the right one? Well, that's what we need to do. That's what we need to figure out. And what I do is, so I will create this plain text, but I don't really know if it's the right one yet. So what I do is I get a score for it. Right? And I'm gonna do this a bunch of times, and everyone's gonna have a score, and I'm gonna grab the highest score. So where does that score come from? That score comes from the scoring function that we created earlier, called the fitness calculator. Right? That's where our score comes from. And what we do is, one of the arguments for that fitness calculator is this quadgram dictionary. So, and so I do every mapping. I do a key of 0. I do, and I go, create a plain text, score it. Key of 1, create a plain text, that'll be a different plain text, give that a score. And I'll go all the way through all the keys from 0 to 25 because that's 26 different ones. That's because that's every possible letter in our alphabet. And I create a plain text and a score. So, and in fact, I will create a tuple that has the key, it has the plain text that I created, and a score. And there will be 26 of these with the key of 0 and 1 and 2 and 3 and 4, so on. They'll each have a different plain text, they'll each have a different score. I will then sort it based upon the score. So I'll make a list of these, I'll sort it, and then I will print the top 5, such as shown here. And we don't show the whole plain text, we show the first, whatever it is, 35 characters of it. And so in this case, the first one had a key of 4, there's the string, and there's this fitness. And because these are negative values, right, these are ordered from largest to smallest. And so we take those, and we print out the first 5. We only printed out, well, the reality is that if you're doing this, you print them all out, and you just, can I in fact read any of them? And it turns out you can. So it is paradoxical yet true, blah, blah, blah. All right. So our function worked here nicely. And what we then do is we say, well, let's just take the first one and print it all out. Now, one of the things here with this type of encryption, you'll notice that there are no spaces and there's no punctuation. And the reason for that is that if you've encrypted something and you want to make the decryption harder, then the bad guys, or not bad guys, the people who've done the encryption know that spaces and punctuation provide clues. So they remove the spaces and punctuation before they do the encryption. So that's why this comes out with, and the same thing, upper and lower case can provide clues. So we make it all uppercase, we remove all punctuation, and we remove all spaces, because those are all clues to the people trying to crack this encryption. And that's why it ends up looking this way, because those clues are removed. So that's the process. And again, this will be in multiple stages. The very first thing we do is we create 26 of these decryptions. We put them in a list, then we sort them, we print out the top 5, and then we take the top 1, that being the important thing being there, that key, and then we'll print out not just the first 35 characters, but print out the whole thing. So there you go. That's a little bit about this this project. Still a lot of details in there. It's quite a bit shorter than the last one. Hopefully that gives you enough to get started with it. Good luck.